Yeah, so we're talking of these last 3 points there. Let me take the mouse, the cursor here. Right? We're talking of these last 3 points, and they seem to be the same height, and they seem to be a constant value from the 11th point onward. So let's think of this. Let's put this in perspective. Let's come up with a hypothetical situation. Let's come up with an assumption that this represents something, right? Uh, it could be anything. That's funny, right? It could be anything. These points could be talking of or representing anything in your daily life as well. For example, the x-axis here, which is from the left to the right, if this x-axis represented consecutive days, and then your y-axis, which goes from here, from the bottom to the top, represented the time it took you to reach office. Yeah, I'm saying it took you because you cannot say take you. It takes you because you already have the data here, right? So you're talking of past. You're talking of history here. It could be history, recent history as they call it. I don't know what that means. It could be old history, if that makes any sense. But yeah, what I'm saying, it's a history. It's past data. Okay, so if the y-axis represented the time it took you to reach office, this little point here, this specific point here, dot here, would actually represent the time it took you to reach office on the first day, right? So this is the value of time, and then this is the first day. Similarly, this little point here, the second point here, would represent the time it took you to reach office on the second day. It goes on like that, third day. Then on the fourth day, this is what you can see. There's a little, yeah, there's a descent here, right? It climbs down. So what would that mean? Talking of the example that we have here, so it would mean that you took less time to reach office than on earlier days to reach office on the fourth day, right? And then it all of a sudden shoots up, goes all the way. You took a really long time to reach office, blah blah blah, coming down, and so on, right? Goes on, goes down, and then so we have 12 days here, right? So on the 10th day here, you seem to on the 10th day here you reach here, and then 11th you are constant. You took the same time as you took the earlier day. On the 12th you took the same time as you took on the past 2 days, on the earlier 2 days. So what does it mean? You don't need to be mathematically inclined to figure this out, right? Yeah, tell me what does it mean? Okay, let me first go ahead. Yeah, we'll come to the whiteboard now in a minute. So yeah, this is what it means, right? There is variation. There isn't a constant value. The value or the time that it takes you to reach office is not stable. It's not static. It is not one value. There's deviation, right? And then toward the end you tend to seem to have some kind of control over how you go to office and whatever that means, and you seem to have taken the same time to reach office for 3 days in a row, which is good, right? So sigma, as we're talking of, represents variation. Well, it's a little different from just a deviation from the expected value, because in that case we'd be talking of a series of values, right? We're talking of either a sample, which we'll again explain later, or a population. So that's a little different, but on an average or at a high level, it does talk of deviation from a standard value.